Hey folks, Sebastian here. Welcome back to another development video. So the game you're seeing in front of you right now is Project Slide. It's a game that I'm working on using my own game engine and tools. And I haven't put out a video in a while, and I figured I should put out this update video to show you what I've been working on lately. So, as you may or may not know, I've been working on this area that you see. This is the sort of prototype level for the game. In addition to actually being an actual level, an area in the game world, this is a prototype level in the sense that I use it to establish the art style for the game and lay out the workflow for actually creating assets for it, determining the size of the level, etc., etc. And I think it's actually going pretty well. As you can see, there's still some assets here that need work. Here we have a building without any textures, for example. There's some foliage work that still needs to be done, things like that. But overall, I'm actually quite happy with it. However, there's been one area that I've been sort of not that happy with for a while, and that's been the actual lighting model used to light this thing. And since this is a self-made game engine, the idea has never been to take on the big engines, your Unities, Unreals, that kind of stuff. But I still want the lighting to look pretty nice. And so to that end, I've worked for about a month now on a global illumination system for the game. And so I figured maybe I can show that to you today. So this is a system that's still heavily in development. There are some problems with it still, as you'll see. And also, like I mentioned before, I'm not really a graphics programmer, so this is really kind of me trying things out and seeing what works and what doesn't. But I'm actually kind of happy with how it's turned out so far. So let's see what we have. So we have a couple of new toggles here. Essentially, the global illumination or GI system is split into two. So we have light maps and we have light probes. And let's toggle these off individually and see what happens. So in the current place in the level, the most obvious difference comes from light maps. So without going into technical detail yet about what they do and how they work, you can see that when we disable them, parts of this ravine here get almost like artificially lit. Like these are way too bright to actually look like they're part of a ravine like this. And when we turn the light maps back on, they get more of a sort of like a gloomy, darker feeling to them. And the light probes are currently mostly visible on the car and on these branches. So we can actually probably make it more visible if we turn them off and then we drive this car down into this ravine. And you can see that it looks kind of wrong. Like the car looks almost like it was artificially lit by something. The car shouldn't be this bright when it's standing in a ravine like this. Now if we turn them back on, the lighting becomes much more realistic. You can see that there are these parts under the car that are actually very, very dark because there's very little light coming from this bottom and lighting it from the underside. And the same thing can be said for these trees here. Oh, and yes, I should mention that these particle systems that you see, which, like, in addition to actually looking pretty bad still, they aren't using the GI system yet, so they look way too bright too. But that's not something that I've done yet. But yes, these trees, in particular the branches, are also using the light probe system. So you can see that now they look very sort of flat, like they don't really belong in this space. And when we turn this on, they do. Light probes are actually used to light these small pebbles and this fern here too, but actually those objects are kind of packaged into a slightly more efficient data structure in the game, which means that debug toggle doesn't work. But I can show you them in the editor. So actually we can perhaps go there. So in the editor, every single fern and pebble is an actual game object, and the debug toggle toggles the game object. So you can actually see the difference here, like this. You can see that the ferns and the pebbles or rocks, and these are actually sort of to scale. They're quite large, but like compared to all these other ones, they're very small. They also look like way too bright without the light probe system enabled. Okay, so that's cool. We also have some very cool lighting going on under this building, for example. Without the light maps, this just looks way too bright, and the light map sort of covers that and takes care of it for us. So maybe we can actually talk about the light maps a little. So how does it work? I'm actually trying something new here. I'm trying to actually annotate this for you, or sort of draw it out. So let's see how this works. Never really done this before. So if you have like the level, something like this, and you have the ground here, and then you have a sun. Sun is shining over here, and you have. Let's actually just draw that building that we were just standing underneath. I don't know, something like this. And then we have the base sort of coming down over here. So it's kind of obvious to us that as the sun rays are sort of shining like this, the building produces a shadow, and it covers this area underneath it. But actually, as the sun is shining, maybe there's another cliff wall over here. As the sun is shining, the light actually bounces off that cliff wall, and it enters this space, and that happens for all places in the scene. So there is light sort of entering the space from other places in the scene, just not directly from the sun. And that's what we mean when we say global illumination, because it's kind of global. It's indirect. It's both direct and indirect. And you can calculate as many of these bounces as you want essentially. And obviously that's going to take longer and require more processing power, but it can be done, and you get more and more realistic results. So that is what we can see here. We're standing inside of a funnel tower. So you can see sort of like without the light map, this place here, the gravel, is almost the same color as here. Actually, we can turn off these selection boxes so they don't mess with our demonstration. This is in shadow and this is in shadow, so they look essentially the same. But when we enable the light maps, this becomes much darker than this area here. And this is because this area receives much more indirect lighting than this one does. Even though they're both in shadow, so they don't receive direct sunlight, this receives more sort of bounces from all over the place than this one, because this is sitting underneath the building. And so the way we do the light mapping is essentially we have the scene again like this. We have some rock here. Actually, we can just put in the same building again to help us illustrate it. We actually want to cover the whole scene in a texture, essentially. And then we want to render the scene from the point of view of each texture. So essentially we place a camera here and we render it that way. Then we place a camera here and we render it that way. And the rendering essentially does it samples all the light that is sort of entering the camera as it sits right here. And the value that we come up with, that will be the value for the light map. And in fact, this angle here, this field of view, is quite silly. It would actually be sort of, if this is the point that we want to sample, we actually do sort of a hemisphere. So we render in all directions like this. And we come up with a value for the light map. And so we render essentially all the light that is entering from all directions, and here we have maybe something that has bounced off the ground and then comes back up like this. And that makes sense that these points underneath the building are darker, because we have a point here and we have lots of sunlight entering it, and we have light coming from all directions, even from under here a little bit. This gets a higher value than this guy here. There's still some light entering from the sides, but there's almost no light coming from straight from above. There might be a little light coming this way, bouncing up to the ceiling and then bouncing down again. But still, it will be darker than this place over here. So what does that actually look like in the editor? We have a debug view here that we can enable, and immediately we see that these buildings aren't actually light mapped yet. So they don't benefit from this system yet. However, the ground underneath them are actually light mapped. So they do. And everything that currently gets light mapped in the debug view gets this grayish color applied to them. And this is the raw light map value. So this is a debug view that I've enabled. And you can see that particularly in these sort of crevices, the light map gets darker values. We have some artifacts here that I'll come back to in a bit. And yes, like I mentioned, this is a work in progress still, so there's bound to be some issues. But here you can see that essentially the whole scene is light mapped. I think actually everything in this part of the scene is currently light mapped. And you get some really nice natural looking effects, like for example this darker section here underneath the wing of this wreckage has like a slightly darker tone, and it's not something that is immediately obvious to you when you look at it like this. It's just like, yeah, looks quite okay, but when you disable the light map, it looks almost like wrong. It looks like artificially lit somehow. So these are the kind of things the light maps are really nice to like help you sort of establish a sense of place. Same thing with this very nice soft shadow under the wreck from this side. You don't really see it until it's taken away, and then you're like, what happened? This looks just positively awful without the light map. And same thing also with this bridge. Like if you disable the light map, it looks extremely flat and boring. So these are the kind of things that light maps are really nice and and they model very well. Another nice thing with light maps is that you don't really have to do anything. You only have to enable light maps for the materials of the objects that you want to actually light map. And so that's the problem currently with these buildings here. Like this building is obviously placeholder, but even these buildings here, they haven't had the light mapping enabled for them in their materials. So when we toggle this on and off, you can essentially see the dark here, the darkness getting added to the terrain light map underneath these mobile modules here. But they themselves don't actually they don't benefit from this lighting yet, because it hasn't been enabled for them. There's a building over here where it actually has been enabled. So like if we look at this guy here, when we enable and disable the light map, you can clearly sort of see, you can see this tank here like casting a shadow onto the wall of the building, etc. So these are just things that we need to enable for certain objects like these buildings here. So the light mapping is done completely offline. It's an offline process, and this light mapper is currently actually quite slow. It takes about 10 hours or so to bake the whole level, this level here. And it uses, like I mentioned, we actually render each texel in this light map. We place a camera there and we render it a number of times. And that's how we produce these light map values. And it uses just the normal renderer, and it's not really optimized for that sort of thing. So I think some big engines out there use some kind of ray tracer or something like that, but I haven't gone that route, because I wanted something that was kind of quick and easy to throw together. I think this works actually quite nice. And yeah, it's more obvious in some places, such as this ravine here, than in others. But yes, it's an offline process. It's completely static. But on the other hand, it's actually very performant at runtime, because you don't really pay any calculation costs. It's just a texture lookup. Some other silly things that you can see here is that like this patrol route object, which is strictly an editor side object. The material for this is or was apparently wrongly set up when I baked this, because it's actually casting light onto this ground here, which is kind of silly and completely wrong. But it highlights a very interesting feature of light maps and global illumination overall, in that you actually get this nice effect where here, for example, the sun is shining from over there, shining on these leaves, and they sort of cast a little light. They bleed a little of the orange light here onto this rock. It can be quite difficult to see, but it's a very, very subtle effect, and it can look quite nice. Same thing here with these orange objects here. You can very clearly see like an orange tint or hue around this area, where the light is kind of bouncing all over the place and hitting the light map. So I quickly touched on the subject of these artifacts that we can see here. Like here, for example, you can see this edge here is clearly like a UV seam, and there are some really like large texels here that are sort of bleeding through. These are mostly because the light mapper hasn't been properly tuned yet, but also because typically when you use light mapping, you actually dedicate a UV channel like the second UV channel, for example, to light mapping. And I haven't done that yet. I don't use overlapping UV islands when I texture objects, which means that I can actually just use the normal, the first UV set for light mapping as well. But it's not really optimized for doing light mapping, and that's why you get these kinds of light bleeds. Or that's one reason why you get these kind of light bleeds. However, it's not actually as bad as it might look like. If you enable this, like you don't really see those at all. You can see them in some places, particularly these UV seams can sometimes be a little more visible. Well, it's not actually as bad as it might look when you're just looking at the raw light map, but it's still something that I want to actually look at later. So let's actually have a look at what the light map looks like. So here we have the light map or the light maps, shall we say, for the level. So it's a 1K texture array with currently 12 slices. So here this is obviously like the terrain, one of the terrains, and here you can see the ravine that we were talking about. And again, you get this very, very nice and smooth sort of gradients. Like up here we have a lighter tone, and then it just like becomes darker and darker, and this again is the underside of that building that we talked about. And here we have those orange parts near the old Arkship wreck. So that's one page, if you will. We can go to the next one. You can see that okay, here's another terrain. This is actually getting stretched now because the terrain is not a square, but here we can see the dropship wreck with the engine, the wing casting this shadow here. And then as we go forward, we can see these are some cliffs here. How much UV space they get in a light map is determined by how big the object is in the world, and you can override that if you need more. And so we start getting smaller and smaller. These are probably cliffs as well. And I think like at the end we have mostly trees. Yeah, so these are the trunks of the trees. So even if we don't actually use light mapping for the branches, as we'll see shortly, the actual trunks they're light mapped, so you get this very nice sort of shadow here, like darker side on the trunk because it's facing this rock wall, compared to if you went without it. It just looks flatter. Okay, so that's light maps. And so light maps are really good for like most of the environment, but it only works with static objects. So what about light probes and dynamic objects? And light probes are essentially, in a way, they're very much the opposite of light maps. They do work with dynamic objects, even though they're not completely dynamic currently. They don't take very long to calculate, but on the other hand, they do require quite a bit of manual work. So what is a light probe? Well, if we enable this option, draw light probes here, we can see that the whole scene is essentially flooded with these spheres, these balls. And as you might imagine, these are light probes. So it took me about a day to actually place light probes throughout the whole level, and I may have may have gone a little overboard. I may actually want to remove some of them, but this is a first test, shall we say? And here is a pretty good place to explain what light probes do. So if we take one of these spheres, you can see that they sample the lighting around them. So you have this side here where this light probe has picked up on this lighter, this more bright light, and then the other side of it is more like darker and bluer. And these probes that are sort of furthest from any opening, they are definitely darker. And you have this light probe which is very dark here, and then this one which is clearly picking up on this opening here, this hatch, while still picking up some of the dark light on the other side. And so a light probe essentially samples the lighting at a particular point in the level. We have some over here as well. Oop. Let's not go that far. And again, you can see them sort of picking up on the darker places in the level. And there are some artist-controlled perimeters that you can artificially make one of them darker if you want to go for like a more dramatic darkness somewhere, or whatever you want. And so, how do we use these? Well, the probes are not just placed in the level. They form what is known as a light probe mesh, which we can see here. So just quickly looking at this, it looks like a very big mess. But a key takeaway from this is that the system essentially generates a convex mesh out of this. So that's why you see these very, very long edges here that the system has placed where there hasn't been any probes. And then wherever there is a probe, the system places essentially a vertex of the mesh. So if we move one of these now, it will regenerate it. And the idea is that we're dealing with a tetrahedral mesh. So I'm going to try to explain what that is. Okay, so let's say you have a triangle here. You have 3 probes like this, and they form a triangle. For this to be 3-dimensional, it requires one more vertex somewhere. So let's put one up here, and this is now a tetrahedron. It is essentially the 3D equivalent of a triangle. And since each of the vertices is a probe, we essentially get 4 different samples of the lighting at these points. And the light in these light probes is encoded using something called spherical harmonics. And that's a math concept that I'm not going to pretend to completely understand. But the nice thing about, or one nice thing about spherical harmonics, so spherical harmonics. And one nice thing about this is that we can encode the whole low frequency lighting using just 9 vector trees. So 9, instead of having a cube map or something per probe, we just have 9 vector trees. And that's one reason why you don't see these probes containing any sort of high frequency data. It's just this kind of like very, very smooth gradients from one color to another. And that is something that comes from the fact that we're using spherical harmonics from this. But that sort of low frequency color data is exactly what we need and indeed want from a global illumination system like this. So another very interesting and useful property of spherical harmonics is the fact that we can interpolate these values called coefficients. So if we know what the lighting looks like over here, over here, over here, and over here, and we happen to sit over here, we can actually calculate the distance from each of these using barycentric coordinates. So essentially standard triangle coordinates. And we get interpolated coefficients. And we can use those to reconstruct the lighting data at this position. So now that we know that, it's not difficult to understand how we can actually sample the indirect lighting in the whole scene. Because if we look at if we look at how this mesh is split up, you can see that we're dealing with the tetrahedra here. Well, actually, it's kind of difficult to see because we have so many long and tall edges. But here, for example, we have actually two tetrahedra. So we have one vertex over here. Oh, let's not do that. Let's make it show it again. One here, one here, one here, and one here. And that makes one tetrahedra. And another one is right next to it, so it shares three vertices with it, and it has this one instead. And so let's see if I can actually demonstrate this to you. So we have something called a light probe mesh tester, and let's fly somewhere where there's like a more distinct color. So perhaps like right next to this orange object here, and we'll place a tetrahedral mesh. We'll want to actually copy the path and then just add one here, and we'll paste it in. I'm trying to work without a keyboard currently because I'm sitting next to my drawing screen, so it makes stuff a little tricky, but I think we can manage. So this guy, which actually looks very much like a probe, but actually isn't. So this uses the system to test the light probe mesh. You can see as it is sort of getting closer to this probe here, it assumes that probe's lighting information. And if we move it closer to this probe over here, it sort of loses that orange glow that it had when it was closer to this one. And we can have it show which tetrahedron it is currently inside. So you can see that as we move it through the scene, it shows us which tetrahedron in the mesh it is currently using. And so it's interpolating between the probes, making up those tetrahedra. And some of them, as you can see, are actually quite weirdly shaped. So the idea with how these probes are placed is that in open spaces where the the lighting doesn't really change. You don't really need any light probes. Like here, for example, this place is wide open. So the ambient light is going to be the same here as it is here. But closer to where you actually have like edges of shadows and things that you want to actually capture like a change in the lighting, you want to place more of these probes. Now I'm not actually claiming that my placement here is very good or makes a lot of sense, but it seems to work quite all right. Right, so the obvious reason to use light probes for a system like this is to, of course, light things like this vehicle here. Which for some reason doesn't. Oh, right. I'm toggling the wrong thing. Yeah, because this is a dynamic object, just like the light probe mesh tester. This also moves through the scene and samples the tetrahedral mesh in the same way. But there are other reasons to use light probes, and like I mentioned, like these leaves also use it. Here out in the sun, it doesn't. You can just barely see that there's like a little difference there on the bottom side. But if we go somewhere where we're completely in shadow, you can see that they look very flat without it, and actually having light probes enabled makes a big difference. And these are animated, so that's one reason why we would not want to light map them. But the animation is so subtle that we could perhaps even get away with that. However, the geometry is kind of tricky here, so I doubt I would actually get any kind of sensible light map out of this. And to top it off, these are actually double-sided materials, so it just makes it even more tricky to get it to look right. And then, of course, we have these like rocks and pebbles and whatnot that I've also opted to use the light probes for, because everything that you light with a light map needs to allocate some space in here. Actually, get a slot in these textures, and we have thousands of these rocks in a level, so. They're small enough that we can easily get away with just lighting them through light probes. Yes, but yeah, I think my favorite use for the light probes are definitely the vehicles themselves. They just look like they belong so much better in the scene if they are actually using light probes rather than just relying on the static lighting. Like here, for example, when you drive under this, the vehicle just looks so much more like it is actually under the building. So that's very nice. Okay, I think this pretty much covers the GI system for now. If you've made it this far, I thank you for your time and interest. If you have any questions or comments or anything, just let me know in the comments, and I'll be back soon with more videos. I think we'll spend a little time fleshing out some of these assets on video, and I think, for example, this the pit that we just drove past. This is an object that will benefit actually quite a lot from light maps, because this is kind of an enclosed area, so I'm eager to see what this will look like with a proper material and light maps applied. So that'll be fun. But yes, I'll end the video now. If you like this kind of stuff, make sure to like, subscribe, do all the usual YouTube things, and I'll see you in the next one. Bye.